there, this is Nikki Jackson, one of the adjunct professors for Concord Career College, and I'm going over homework for Module 5. So hopefully you can see this particular problem right here. Given to you, you have a fraction, and here are the answers. In just a moment, I'm going to show you how we actually got those answers because it's dealing with exponents. So pay close attention to what you may see. Again, you're dealing with exponents. So for this one, I'm going to have to do a lot of zooming in and out, so my apologies. You have a negative exponent. So with your negative exponent, that means everything is flipped. So you take the reciprocal. So let's look on the inside of the parentheses first. Notice how you have a -1 and a -3. As previously stated, when you have a negative exponent, everything flips. So now you have to flip it. Well, let's look on the outside now. On the outside, there's also a negative exponent. So now you have to flip it again. So right here, where you get your final answer, multiply your exponent. So you have 1 times 4, which gives you 4. Then 3 times 4, which gives you 12. You can't simplify anything because these are 2 different variables. Therefore, you have your final answer. But be mindful, when you have negative exponents, you have to flip each thing. Your next example, and hopefully you can see it, I'm showing you all of it at one time. So we're looking at number 2. You have it given to you. So notice when it says indicate and find the product. So by definition, the product means that you actually have to multiply items. So what you're going to do is multiply your coefficients, and then you're going to add your exponents. So once again, I got to do a lot of back and forth so you'll be able to see it. So here goes the problem in its entirety. So notice I grouped them together. So I have my coefficients, which are 3 and 4, put them together. Then I put my x's together. Now right here, notice how you have 1x right here and then -2 right here. So to combine your like terms, we're going to add the exponents. Hence, for your y's, you're going to have -1 plus 3. So again, you multiply your coefficients, which gives you 12. In regards to your exponents, you're going to actually add. So 1 minus 2 gives you -1. And then for your y exponent, you're going to have 2 because -1 plus 3 gives you 2. You're going to rewrite it using only positive exponents. So note that anything that's on a negative is going to be on the bottom. Therefore, your final answer will be 12y squared over x. So hopefully you have noticed now that all of homework 5 is pertaining to polynomials and exponents. So your polynomials are just a bunch of terms with the variables and the exponents together. So right here, I'm trying to zoom in as much as possible. Number 3, it wants you to indicate the operations. So you got subtraction and addition. So another way of saying that is combining your like terms. So again, my apologies, I'm doing a lot of zooming in and out. So here goes the problem in its entirety, showing you how we did combining like terms. So notice how you have x squareds in one set, then just your x's, and then just your constants. So I rewrote them, and I rewrite by combining like terms. So now you have 5x minus 6x plus 11. Notice this minus sign right here, so that's why it's a -6. Then you got your x's, so you got a -x. Note, 2 negatives make a positive right here. Therefore, we got the positive 10x right here. And then bring down your 4x. Now we have our constants. So we got -8. This minus is going to make that plus a minus. Therefore, it's a -2. And then bring down the -6. Once you combine all your like terms, you now have positive 10. Because 5 plus 6, I did something wrong now. What did I do wrong? I'm trying to figure out how did I do all this. Oh, never mind. I'm so sorry. 5 minus 6 is -1. -1 plus 11 gives you 10. Bring down your x squared. -1 plus 10 gives you 9. 9 plus 4 gives you 13. And here we have negative 8 minus 2, which gives you negative 10. Negative 10 minus 6 gives you 16. Now be mindful of the rules of integers, so you got to be careful what is what and when. You might want to use your calculator for that one. So right here we did combining like terms. Your next example is pertaining to products. Remember, product means that you're going to multiply. Sum, you're going to add. Quotient, you divide. And difference, you're going to subtract. So this one says find the product. Notice how you got your answer right here. So what they did to get that answer was this. So here's the initial problem. We're going to multiply the coefficients. So negative 7 times 2 gives you negative 14. You're going to add your exponent. So it's 1x right here and 4x right there. So 1 plus 4 gives you the 5. And notice how there's only one y. Hence, you're going to rewrite the 1y. So notice again, you add your exponents. We're going to do one more example pertaining to your exponents. Except this time around, here's your actual problem. It's asking you to find the quotient. So by definition, quotient means division. So let's see how they got that answer. So here's the problem in its entirety. So this is division. So I'm going to write it down up here on the side. Divide. So 1 goes into negative 34 times. Notice right here, you're going to subtract your exponents because you're dividing now. In the previous examples, when we were multiplying, we add the exponents. When we divide, we subtract the exponents. So 8 minus 4 gives you 4 x's, so the x4 goes on the top. Then right here, notice how you got your y's. So 5 minus 1 gives you 4. Then 8 minus 5 gives you 3. Because nothing was negative, all of the exponents remained on top. So hopefully you're feeling pretty confident about that. Next, we're going to move on to number 6. Now, so I won't have to do so much flipping. I'm just going to give you examples of the problem along with their answers. So here goes one. It's also dealing with multiplication. So this is what we call distributive property. So we're going to multiply everything. So 2 times 5 gives you the 10. You're going to add your exponents. So 1x plus 1x gives you the 2x. 1y plus 2y gives you the 3y. Then bring down your plus sign. Then 2 times 3 is 6. Same thing with your exponents again. You're going to add. So 1 plus 2 gives you 3. Then 1 plus 3 gives you 4. So your final answer is 10x squared y cubed plus 6x cubed y to the 4. So they might be going kind of fast right there. So make sure you pause it so you can have a better understanding of it. We're going to do another example dealing with the FOIL method. Now this is a lot right here when you're dealing with the FOIL. So FOIL is another way of saying distributive property, but you're going to multiply. So I wrote out FOIL right here. And what FOIL means is your first, outside, inside, and last. So here are your two binomials. So you're going to multiply the first two terms in each set of parentheses. Therefore, you got your x squared. Then you're going to do the outside, which would be these two, the x and the 10. That gives you the 10x. Then you have your inside, which is your 6 and your x, therefore 6x. Then your last set, which is the last terms in each set of parentheses, which gives you 60. So you're going to rewrite it. Notice this part right here, you're going to combine your like terms. So 10 plus 6 gives you 16. Therefore, your overall answer is going to be x squared plus 16x plus 60. Here's yet another one pertaining to FOIL. So my apologies, be patient while I try to get it in focus. Notice how you have x minus 7 squared. Now what the squared means is that you're going to have x minus 7 twice. Therefore it's written out right here. Once again, using the first outside, inside last, you're going to multiply. So that's the same thing as using distributive property. So each term is multiplied to the other term. So for this one, we had x squared minus 7x minus 7x, and then two negatives give you a positive, so that's where the 49 came from. Rewrite it in descending order. What I mean by descending order, notice the number of x's you have. So you have 2 x's, 1 x, and no x. The 14 came from the 2 sevens. Still more details or information about 4. Here goes another one. Now this one's being kind of selective because notice how they're the exact same thing except your signs are different. This one is a negative, this one is a positive. So when you do this, you got to be very, very careful with it because something will be eventually canceled. Again, we're using the FOIL method. So 3 times 3 gives you 9. Notice how we added our exponents right here. 3y times 1 gave you the 3y. Negative 1 times 3y gave you negative 3y. Then negative 1 times positive 1 gave you negative 1. When you're still combining your like terms, these cancel out. Therefore, your final answer is going to be 9y squared minus 1. This is also considered I'm trying to find out a special word for it, but it's dealing with your differences because you're dealing with two different ones. So I'm going to say it's a special product because they're opposite signs. Here goes number 10. Now be mindful these problems may not necessarily be in the same order when you do it for your homework, but if so, they should have the different numbers as well. So for 10, it's asking you to factor. So given to you, you have 15x cubed y4 minus 39x4 y cubed. So what I'm saying right here is that factoring is dividing the coefficients and subtracting your exponents. So what you have to do is think about what number can go into both 15 and 39 at the same time. Well, we came up with 3. Then you have to compare all of your exponents, aka your variables. So I see 3 right here, but 4 right here. Well, if you're counting 1, 2, 3, you got to get to 3 before you get to 4. The same thing with your y's. So you can factor out the x cubed and a y cubed. Now let's do the division part. 3 can go into 15 5 times. 3 minus 3, that should give you, did I do something wrong? I think I did something wrong, y'all. I did. I totally did something wrong. There shouldn't be an x right there, y'all. Because 3 minus 3 gives you 0. Then we got the 4 minus 3 is the 1. Bring down your minus sign. 39 divided by 3 is 13. So with your x's, 4 minus 3 is 1. And then your y's cancel out. So your final answer rewritten looks more so like this. So my apologies, I made a mistake. By the way, I'm human. I'm probably going to make some more. But this is how you factor. Moving on, we have one pertaining to simplifying. Notice right here that both of them have the exact same thing in them. So you have this part and this part. Therefore, automatically, the 2a plus b is part of your answer. Now look on the outside. You have 7x minus 2y. So you combine those. So now you have the 7x minus 2y and then bring down your 2a plus b. What you just did there was factor by grouping. Once again, my apologies for going so fast on the videos, but I'm looking at how many bytes each one of these videos has to be. Going on to your next example. This is a long one. Another one, this is still pertaining to factoring by grouping. So let me write that out. So in this case, we're trying to group all our variables together that look alike. So we got 2AC plus 9BD, 2BC plus 9AD. So, what can we do to make it look alike? Now, of course, there's always more than one way to do math, and you still get the same answer. But what I'm going to choose to group, let me get my C's together. So right here, we got the C's. And right here, we have the D's. Now, you could have grouped them with the A's and the B's, and again, you still would have came out with the same answer. So right here, I can factor out the 2C and come up with the AB. Right here, I can factor out the 9D and come up with AB or BA. Now, pay close attention to this. AB and BA are the same thing. And the reason why they're the same is because addition is what you consider commutative, therefore it's going to be reflective. So the order does not matter when you're multiplying or adding. So notice again, we're doing the grouping. So here goes the outside. The inside, even though they're in different orders, it's just like a mirror image of each other. So you can say 2C plus 9D times AB. Now we're doing a different type of factoring. This was considered the difference of squares. Now we did one similar to this earlier, and I said it was a special product. So your difference of squares is where you got a squared minus b squared equals a plus b and b minus a. In this particular example, your a is going to be -2, your b is going to be 9y, and I said -2, I meant to say -2x and 9y. Here's how it gets confusing. Notice how it says squares. So think about, what is the square root of 4? That gives you 2. Because squares are relevant to 2, so that's why you just have that 1x right here. Same thing for 81. What's the square root of 81? Gives you 9. Since you have 2 of these, you just factor out by 1, so therefore you have the 9y. Following these rules, notice how a was -2. When you factor it, that's your final answer. I also encourage you to check this by using the FOIL method. So if you did the FOIL method, that would be -18xy plus 4x squared minus 81y squared plus 18xy. So these cancel out, and voila, we just checked it. Here goes number 14. Again, this is a sum of special, it's a special product. You know that you're doing the difference. Well, the first thing I did that I factor out the 9, because 9 can be factored into 36 in itself. So therefore, if you divide it, you're left with the x squared, and 36 divided by 9 is 4. Well, this is a perfect square, this part right here. So let me show you what I did. To get from here to here, we know that you have to factor. So there's going to be 2 binomials. So you know you got an x, and you know you have to have 2 of them. What gives you 4 when you multiply? So that will be 2 and 2. But notice how there's no middle term. Therefore, that's how you know that one of these signs has to be positive and the other one has to be negative. Therefore, your final answer with the 9 is going to be 9x plus 2 times x minus 2. I know that was kind of tricky right there, but if you go on to Canvas and look under Module 5, one of the assignments is considered with your factor table, so you can see where I'm getting the 4 from. Here's another one. Now you might want to write this one down because it's quite a lot. Here you have a cubed minus 27. So this is the formula that you need to write. So yes, I'm saying write this right here, because you're going to have to use it for your exam or end of assessment. So you're going to have a cubed minus b cubed. When you factor it, it's literally going to be a minus b times a squared plus ab plus b squared. So I substitute everything in for my formula. So if I'm looking at this carefully, I don't have a coefficient. Therefore, a is going to be what a is. And I got to think hard about what the cube root of 27 is. So that's going to be 3, because that's 3 times 3 times 3. Therefore, that's 3. I'm going to follow the formula and substitute my values in for A and B. So I know that A was A itself, B is 3. Still going by this, I got A squared plus 3A, because notice as it says A and B. And then B squared is going to be 3 squared, which is 9. So this is your final answer. You might want to pause the video right now so you can go over it again. Here goes another one in its entirety. I'm going to have to move it up and down for you. It wants you to solve for x. Notice how there's x squared. So I'm going to add 81 to both sides. So now I got x squared equals 81. Now hopefully you can read this part right here. Since squares can be both positive and negative, find the square root. Now remember, 2 negatives give you a positive. So from here to here, the opposite of something being squared is going to be the square root. Because both of them can be positive and negative, you're going to take the square root of 81. That's going to be 9. But this little funny symbol right here means positive and negative. Therefore, your final answer can be negative 9 and 9. Now here's one. Again, you're dealing with everything as far as a polynomial. Now what I sketched out right here is pertaining to the factor table. That's, again, it's already posted in Canvas. You want to factor it. And the question is, what gives you 30, which is this part right here, when you multiply, but then when you get a negative 11, when it's added. So what I did right here, I had to think about all the numbers I can multiply to get 30. So I got 1 and 30, 2 and 15, and I'm going to stop. Because even if I added or subtracted this, there's no way I can get 11. Same thing with 3 and 10. But if I do 5 and 6, if I get a negative 6 and a negative 5, that gives me an 11. So, how many x's do we have? We have 2, so you write out both of your parentheses. Here goes an x, there goes an x. And the same 2 numbers, which were your factors that gave you 30, which is 5 and 6. Because that is a positive 30, but yet a negative 11, both of them are going to be negative. And here goes your last example for the video. Again, you're factoring the polynomial. So notice it's asking you what gives you 33 when multiplied, but gives you 14 when added. So 33 is special because that's like, I'm going to say an odd number, which it is. So right here you got 1 and 33. That definitely doesn't give you 14. And then 3 and 11. Because 3 plus 11 gives you 14. So notice how I got my parentheses already. So here goes 1x. Here goes 2 x's. Here goes your 3. Here goes your 11. Now we got to determine what the signs are. Notice how both of these are positive. So since both of these are positive, both of these are also positive. This concludes the video lecture dealing with homework